Hello guys, welcome to a new video. In this video we will proceed to explain the final project of the subject of Simulation 2 of the career of System Engineer of the Polytechnic Salesian University. We say that the Montecarlo method is a numeric technical uh, for uh, calculating probabilities and other related quantities using sequence of random numbers and random variables is a function that is assigned a value used numerical of the result of random experiment. The advantage uh, that we can highlight a directed flexing method. Directed and flexing method, there is a wide range of programs and languages integrated to simulate with that mathematical model is to complicate the simulation while obtain an approximation. The simulation is used to formulate extreme conditional with zero risks. The simulation does not interfere with the real world in allow to experiment. Disadvantage: a good simulation can be very complicated and large number of variables. The simulation doesn't generate global optimal solution. It does not provide the decision to take, but is solved that problem by approximate for initial condition. Its simulation is unique, change the intervenes. Now, you proceed to choose the function uh, that must be double integrate to perform the calculate of it. Our choosing function is the following. In this case, you can see, and we'll proceed to graphicate. In this case, choose the function because it resembles a representate a volcano and red. Resolution, the Montecarlo integral must be claimed the following parameters. You can see this variable, which are the points that file with the area. This variable represents the entire area of the function. Variable P, the number of hits. One variable, next variable, the number of errors. You can see graphics to explain the method de Montecarlo. Now, with the solve the function by applying random number, in this case 100, and we can see the result. This approximate a real result. Now we turn to graphic of the function with the area, and we have the figure. You can see the integration in this case in this area. You apply in next graphics and result this graphics. Now we went to solver the integration, the integral with a library that will help you to get to result. This is result and different to apply other library and other method to resolve and exactly to integrate. Now, the calculation of number of interactions. Begin our function, you can see my function. First, we must pass the binomial distribution we have to a normal distribution with the following steps. You can see now n number of the time the random experience of the carry out, p la probability of success, and probability filter. Now after this we calculate the variable z. You can see this formula, you apply this formula. Now we proceed to calculation iteration. Now this is equivalent to the number of hints will 95% to assert. Now, and we'll proceed to perform the calculation. After this value, we can check in the table of the normal distribution. You can see the normal distribution, this value of result to apply the approximate the binomial distribution and normal distribution to value. You can see this value to browse in table. You can see this value. This value. Now, and we'll proceed to perform the calculation of the number of the iteration. You can see they apply the formula and this value similar at this value. Now, to apply the formula, you can see to get this valued iteration. Now, the process resolved to integral in this valued is similar to valued calculation before. Now, when calculate the error for this mouse applet, they form. You can see the applet, the formula, and you can see, and the will to perform the calculation to apply this formula in this part, and this case this value for the line print of the order value. Now, and we'll proceed to make the graphic of the estimated error and the real error. In this case, real error, you can see, and estimate error. This will be all. Thanks for watching YouTube song. Thank you.